Hi there, I'm going to go over an example of how to rotate a conic section. So our general conic section is going to be of this form. Notice that if there's an xy term, we can't complete the square and get something that is familiar to us. So what we're going to do is we're going to go through the process of how to rotate a conic section. Okay, so the first thing we need to do is figure out the values of a, b, and c. Well, in our equation, a is the number in front of the x squared, b is in front of the xy, and c is in front of the y squared. So for this particular problem, I've got a is 1, b is radical 3, and c is 2, because I have a 1 here, radical 3, and a 2. So I'm going to take those numbers and I'm going to put them into the equation cotangent 2 theta equals a minus c all over b. When I do that, I get the cotangent of 2 theta equals negative 1 over radical 3. Now it might be a little bit easier to think of it this way. If the cotangent is negative 1 over radical 3, then the tangent of 2 theta would be the reciprocal, which is just negative radical 3 over 1. So then you can think about where on the unit circle does the tangent equal negative radical 3. Well, that happens at 2 pi over 3. So my angle, 2 theta, is going to be 2 pi over 3. Now I want to find out what theta is, so I'm going to need to multiply by 1/2. And that gives me theta must equal pi over 3. Okay, so now we're ready for step 3. Step 3 is we solve for x and y using the value of theta. And to do that, we're going to need these two equations. This equation takes my x from my normal xy axis and it's going to transform it into a new universe, a translated or rotated universe. So the x and the y represent what we normally would see in our coordinate system, and then these prime values here and here, they tell us what it would look like in a rotated universe. So I'm going to take my value, pi over 3, and I'm going to put it in for theta. Now, I know from my unit circle what the cosine of pi over 3 and the sine of pi over 3 are, so I can put those values in from my unit circle. You can leave it like that, or you could combine them into two single terms. Now I'm going to take those, and my next step is to substitute those values in for x and y in our very original equation. So I'm going to slide this up. Here's my original equation. Now this is going to get a little messy looking because for every x and every y, I've got to make a substitution. This is what x equals. This is what y equals. So my equation said to take x and square it. So I've got to take this quantity and I've got to square it. This is radical 3 times x times y. Here's radical 3, here's my x, here's my y. Then I have plus 2y squared, here's my plus 2, and here's my y, and here's my square. Then minus 2 equals 0, here's the rest of it. So you'll notice that here I'm going to have a binomial that's being squared. Here I'm going to have FOIL, and here I have another binomial that's being squared. So when I multiply all of that out, this is where I end up. Here's that squared binomial. Here is the FOIL. Keep in mind that I had to do FOIL here, and then I had to multiply through by the radical 3, which gives me this quantity right here. Over here I had to square this binomial using FOIL and then multiply through by 2, which gives me this quantity. Now all of this is going to give me this equation right here. So let's clean this a little bit by multiplying both sides by 4 to give us this. Now we know from before that when you have an x squared term and a y squared term, they have the same sign and they're different numbers. That's going to be an ellipse. So for an ellipse, we know that it has to equal 1 over here, so I'm going to need to divide all the way through by 8. When I do that, I can do some canceling that works out great. This gives me 1, and then this 2 goes in here once, goes in there 4 times, but over here, when I do the simplifying, 2 goes in there 4 times and 5 times. So it simplifies to this. Well, the problem with this is if it's in the right form, there should not be a number here. So what am I going to do to get rid of this? Well, there's a little trick involved. I'm going to multiply this fraction by 1 in the form of something over itself. So the something that I'm going to put in here is going to be 1/5. Because if I multiply the top and the bottom by 1/5, then the 5 on the top will disappear. So here it is written out. So I multiply by 1 because this all together is a big fat 1. That's 1. So 1/5 over 1/5 is 1, and in the numerator the 5's cancel, and I just end up with this equation. Now I know that that doesn't look very pretty, but I can deal with this. I can deal with a fraction on the bottom. I'm going to turn it into an approximation anyway. So let's keep going. Okay, now we need to graph the equation. We have our angle of rotation is pi over 3. And now I need the square roots of these two numbers. So the square root of this one will be 2 over radical 5, which is approximately 0.9. And the square root of this one is 2, which is this number. So A is 2, B is 0.9. And we are going to use those vertices and covertices in our rotated universe. So let's take a look at that. So here is my XY axis, and I'm going to bring over another XY axis, and I'm going to rotate that pi over 3 radians, which is the same as 60 degrees, which is roughly about there. So our rotation here is going to be pi over 3. So this is my x-axis, this is my y-axis. In my black universe, this would be my x-axis, and this would be my y-axis. Okay, so now I need to look at only the red x and y axis, and I need to graph my equation. So going back here, it's centered at the origin. I can tell that from this. In the x direction, I need to go 0.9. In the y direction, I need to go 2. So I'm going to mark off my values on my red axis. I can also mark those off on my x-axis and my y-axis like this. But for my x-axis I need to go 0.9, which would be there and there, and then I need to go 2 in the y-axis direction because the 4 was under the y. Those are the points for my ellipse, and I'm just going to go ahead and draw my curve. And what I have in blue is the ellipse. Now if I ignore what I have for my red x and y and look at the blue ellipse in the context of my normal black xy axis, you see that the ellipse is it's kitty corner. It's not vertical and it's not horizontal. It's angled, which means it's been rotated. So now what we want to do is we want to find out what these points are in the black universe. So in my red universe, this point right here is the point 0.9, comma 0, and this one is negative 0.9, comma 0. This one up here is 0, comma 2, and this one is 0, comma negative 2 in the red universe, in my rotated system. Okay, so now I want to figure out what those points would be if I graphed them in the regular xy plane. So let's take a look at what that would be. So if I take the point 0, comma 2, and I want to turn it back into the xy plane, so I want to see what would that be if it was in the regular xy plane, because this is what it is in the rotated plane. So what we would do is take those same two formula equations that I started with, and I'm going to put my point, which is in the x prime y prime plane, I'm going to put this in for x prime and y prime all the way through here. And because I know my angle is pi over 3, I'm going to put that in for theta and see what happens. So when I put those values in and I substitute the values from my unit circle, I get this equation. And if I continue to clean it up, I get x equals negative radical 3 and y equals 1. That means that the point 0, 2 in my rotated xy plane coincides with negative radical 3, comma 1 in the regular xy plane. And I can do that with the other point and get something similar. So let's go back up, negative radical 3, comma 1. So I want to go back up here for a second. In the regular xy universe, this point is negative radical 3, comma 1. So negative radical 3 is about 1.7, so that's pretty close here. Negative radical 3, and then I'm pretty close to the 1. Again, this is just a sketch. If I were using graph paper, it would be more exact. And then this point down here in the black universe, in our regular xy axis, would be radical 3, comma, negative 1. And again, you can see radical 3 is about 1.7, and then down 1. So that's how you rotate a conic section so that you can graph it using the methods that you're familiar with. We know how to graph an equation that's in this form. All we have to do is figure out how much it has to be rotated in order to use that form.